Hi guys, good evening. Right, so welcome to this session where we will focus on doing the 2021 physics paper. Okay, so this session is mainly for Sec 4 students, but Sec 3 physics students also can follow, as well as combined science students also can follow because some of the questions are from the same topic. Okay, so yep. So guys, please get ready your 2021 paper. Now, the thing is, we try to cover as many questions as possible. Okay, we try to cover as many questions as possible, and will be good for you guys to actually share your answers on the chat. Okay, ask questions in the chat. Okay, so let's try to look at it as if uh, all of us are doing the paper together. All right, guys, I repeat, this is the 2021 paper. Okay, so you can refer to your TYS. So let's take this session as if we are doing the paper together, okay? Now, sometimes we may have to go a bit faster. You may have to take a screenshot, okay? But mostly you should be able to write down the answers. But try to do the questions yourself, okay? All right, question number 1. Okay, the kilogram, meter, second are all units of base quantities. Okay, state the unit of one other base quantity. So you know they are all together 7. Out of which we will mainly focus on the other 6, right? We have Kelvin, which is the unit for temperature. We have mole for amount of substance, and we have ampere. Okay, guys, you don't need to write all 3. So let me just put a stroke here. You just, because the question only asks for 1, so I'm just giving you the option. Okay, now anyway, this is from the topic of physical quantities, units, and measurements. Okay, nano. This is 10 to the power minus 9. So that means you should know what are your prefix. Okay, please be careful. Don't use the wrong one. Okay, so this is actually mainly from the very first topic. So you can get questions from that. Okay, next, rearrange the prefix in order of the largest to the smallest. Guys, take note of what they say, largest to the smallest. So we have mega, then this is kilo. Okay, this is deci. Deci is 10 to the power minus 2. And then we have deci is 10 to the power minus 1. Centi is 10 to the power minus 2. So this is the order. Mega, kilo, deci, centi. All right? Okay, always remember, read the questions carefully. Yeah? An athlete runs around a circular track of radius 20 meters. Now, I purposely highlight all this so that I don't miss out anything. He starts at position A and takes 7 seconds to complete half of one lap. Guys, look at that. It's not the full lap. That means from A, let's say he goes from A, let's say he starts go run like that. Okay, he runs like this. And for him to complete half the lap. Okay, look at that. Half a lap only. Now they ask you to calculate the average speed. What is the average speed? Total distance over total time. Guys, please be careful. So half a circle, the circumference of circle is 2 pi r. So half the circle, right? Average speed. So it's just pi times r because it's just half the circle divided by time. So it's pi times 20 divided by 7.5. And you work that out, okay, you get 8.4 meters per second. So this is your answer, guys, 8.4 meters per second with the correct units. Okay, now, what is the magnitude of displacement of point B from point A? Guys, can you tell me the answer? Can you tell me in the chat what is the displacement from A to B? The displacement, the magnitude of displacement. They're asking you what is the displacement of point B from point A. Guys, share your answers, please. So remember, it is the distance traveled in a straight line. It is a distance from A to B in a straight line. So what's the distance, guys? 20, 20. So all together, guys, please take part in the, yes, very good. Okay, guys, please take part in the chat. Yeah, do answer. Okay, 40 meters. Very good. Okay, next. Why? Explain why the average velocity. Yes, very good, guys. Now, explain why the average velocity of the athlete. Now, they said average velocity, not average speed, for one complete lap is 0. Why is it that when the person completes one full lap from A, he comes back to A? So why is the average velocity 0, guys? Yes, the displacement is because when he completes one complete lap, right? Okay, so basically the point here is velocity is a vector quantity, right? And how do you calculate average velocity? The main point to highlight is that the net displacement is the net when athlete completes one lap, he returns to point A. His net displacement is 0. Okay, so remember net displacement is 0. So technically average velocity is 0. So what is the formula for average velocity? Is the total displacement over time. Is the net displacement over time. So when he returns back to A, his net displacement is 0. Okay, net displacement is 0. Okay, everyone got this? Okay, let's take a look at question number 2. Okay, this question is on dynamics, right? Figure 2.1 shows the vertical forces acting on a weather balloon just after liftoff. So they have labeled all the forces. They say the balloon experiences an upward force of 85 Newton and the total weight of the balloon and its contents is 61 Newton. So they said this is the weight, right? So this is the upward force, this is the downward force. They ask calculate the total mass. So you know that weight equals to mg. So 61 m divided by 10. You work out the mass. 6.1 kg, all right? 6.1 kg. Next, if you look at the equation, so you know it's moving up 95 Newton. They said calculate the initial vertical acceleration. The question says calculate the initial vertical acceleration of the balloon, right? Okay, initial vertical acceleration of balloon. Now, they said give your answer to suitable number of SF. Now, here you have to be particular, right? You look at that, all the values are given to 2SF. So guys, we have upward force 95. Now, you need to know how to answer this type of questions. Upward force minus downward force. This is the upward minus downward is your resultant. Now, a lot of students don't know this, that F equals to MA. The F here is actually the resultant. You must remember this is the resultant force. So you do MA, which is 6.1A. So we already know the mass. So the net force is 34. 34 divided by 6.1 A. And that is your answer. K, which is 5.6. Okay, so it's 5.6 meters per second squared. Correct to 2SF, huh? 2SF, okay? You don't need to write 2SF, but I'm just telling you, all right? Now, when the balloon rises, it experiences air resistance. Yes, good. I see some of you answered that for the previous one, net displacement is 0. Guys, can you tell me based on this question, it experiences air resistance. Can you tell me what two factors that can affect the air resistance on the balloon? What two factors can actually can make the air resistance higher or smaller? What are two factors that can cause the air resistance to be affected? So far, the questions, whichever we are discussing so far, in a way are related to combined science. Okay. Okay, correct. You are right. The size, the surface area of the balloon, yes, very good. Surface area of balloon. What is the other one? Yes, very good. The velocity or speed of the balloon, right? Velocity of the balloon. Good. Because the faster you move, the greater will be the air resistance. We all know this, right? Okay, guys, when we run faster or we cycle faster or the car goes faster, the air resistance is aerodynamic shape. Yeah, I mean, that's a little... technically, you are right, lah. But I think for this question, you are right because the aerodynamic shape of it affects it. But I think in this case, I think we are looking at something more direct and simpler answers, lah. The velocity of the balloon and the surface area. But in reality, yes, the aerodynamic shape of it does affect air resistance. So you are right in that sense. Yeah. Speed of balloon, yeah. The velocity or speed of the balloon, you can put speed of balloon. Velocity or speed of balloon. So we just take it as it's moving upwards. So you can put speed of balloon. The upward force remains at 95 Newton. Okay, the upward force remains at 95 Newton. The air resistance increases to 34. So guys, now what happens is the upward force goes up. Now the air resistance increases from 0. It increases. The air resistance acts in the opposite direction, right? Increases to 34. So now you look at the forces, right? If you look at the forces, the net force is 95 minus the force downwards, 61. This is due to the weight. And 34 due to air resistance. So your net force is 0. So F net is 0. So they ask you, describe and explain the motion of the balloon when the air resistance has this value, right? Yes, very good. Resultant force is 0, correct? The balloon travels upwards at a constant speed. Excellent. So balloon, guys, cannot say balloon comes to a stop. Balloon continues to move upwards with constant, continues to move with constant velocity or constant speed because you already gave the direction. This is because net force, we can put down 95 minus 61 plus 34 equals to 0. Hence, acceleration is 0. Okay, no acceleration. Okay, so what actually happens here is when the forces are cancelled, 95. So now the downward force is also 95. This plus this is 95. Hence the net force is 0. Hence acceleration is 0. Okay. All right. So guys, the questions are doable. Okay, all doable. So remember, just to let you know, you see the question on kinematics, right? Okay, last year in the year 2024, they asked about something on a speed time graph or velocity time graph. Then the second question is a lot of times on dynamics. So these two topics, right, you cannot run away from it. They will always ask questions on kinematics and dynamics. It's a popular, both are popular topics. Okay, next, state the principle of moments. Guys, all of you, even combined science students, we need to know. For an object to be in, you don't need to say rotational equilibrium. Okay, for an object that is in equilibrium, the sum of clockwise moments about a pivot is equal to sum of anti-clockwise moments about same pivot. Okay, so guys, take note. For object to be in equilibrium, sum of clockwise moments about a pivot is equal to sum of anti-clockwise moments about the same pivot. Okay, so this is just like a factual thing, right? You need to know how to talk about the principle of moments. By the way, what is moment? Moment about a point is the force times perpendicular distance. So if you look at this question here, right, it says a diver stands at the end of a diving board. Okay, he stands at the end of a diving board, as shown here, right? So they give you the values here. Okay, they say the weight of the diver is one factor that affects the size of the moment. Guys, remember what is moment? Moment is force times perpendicular distance. So if they say that the weight of the diver is one factor that affects the size of the moment of the diver exerts about the pivot. So here's the pivot. So what is the other thing? So obviously you know that yes, very good. The distance. Okay, let's be very specific. The perpendicular distance. Okay, the perpendicular distance of the diver. Okay, the perpendicular distance. The perpendicular distance of diver from pivot. Okay, very good. So perpendicular distance. So because how do I know that? Because moments depends on force, which is the weight, times perpendicular distance. Now, you look at this, right? You see the weight of the diver is 600 Newton. Okay, this is 600 Newton, guys. And they say that the weight of the diving board. Now, a lot of times, right, students forget that the beam or the board on which you're standing has a weight. So a lot of students tend to forget this and forget to take this, consider this moment. So where does the weight act? The weight acts at the center of gravity. So this is 300 Newton. Guys, put this in so that you don't forget to consider this is the weight of the diving board. Okay? This force acts at the center of gravity, which is 0. They already said what is the distance. They gave the distance. This is 0.9. Now this one, please don't just take the wrong value. It's 2.5 plus 0.9. So technically this distance is, please add carefully, 3.4. Now they say the diving board is attached to a fixed base here, and the fixed base exerts a force. So if you know by principle of moments, this one and this one produces a clockwise moment, and to balance it, to counter it, must be the anti-clockwise moments. Okay, so those of you who have worked very quickly, you're already giving me the answer. Yes, your answer is correct. Very good, guys. So yes, if you work ahead, so you know, right? F times anti-clockwise moment. This is the anti-clockwise moment, okay, equals to 600 times 3.4 plus 300 times 0.9. Okay, this is due to the weight and this is due to the diver. So you work this out. This is the clockwise moment. So good. I see a lot of you have actually put out the answers. Okay, very good. So you get 1440 Newton. Excellent. So you can put this answer, okay, 1440. Okay, if you want to give it to 2SF, you can, but remember to have this value. So because later on, you can give 3SF or 2SF, yeah? Okay, now they said, calculate the now this part you need to know. Calculate the upward force that the pivot exerts on the diving board. Guys, remember what they're asking you is what will be the force the pivot here exerts. Look at that. Now, remember, you have to go back to condition number 1 of equilibrium. What is condition number 1? All the forces, the net force must be 0. So you look at this, this force, this force, this force are all acting down. So the force at the pivot is acting up. So the force at the pivot must be, the upward force must be equal to all the downward force. So you can just add it up, 300 plus 600 plus 1440. So you're using the first condition of equilibrium. Net force must be 0. Okay, so I'm using the first condition of equilibrium and I get 2340 Newton. Okay, 2340 Newton. Okay, everyone, okay? So this is how I will do this question here. Okay, yes, I can explain. Why I add it up is because, remember, there are two conditions of equilibrium. One is this. Sum of clockwise moment must be equal to anti-clockwise moment. But there's another condition that you need to satisfy. If the object is in equilibrium, the net force must be 0. So if you look at it, the forces, if this beam is in equilibrium, you see all the forces here are all acting down, right? You look at the forces, 600 Newton, 300 Newton, and you just found this to be 1440. Okay, you just found using the condition of equilibrium. Now, if all these forces are acting down, then the forces acting up at the pivot must be equal to all the forces acting down for the beam to be in equilibrium. Okay, because the beam is not moving up or moving down. So the force upward must be equal to force downwards. Okay, that's why I added up. These are the downward forces. Yeah, net force equals to 0 means, okay, for the question of dynamics, right? That means the force to the right is balanced by force to the left. Force acting vertically up must be equal to downwards. So it cancels out. That means there's no resultant force. That's what it means. That means the net force 0 means all the forces acting to the right is cancelled by all force to the left. All force upwards cancelled by all force downwards. So you make use of that to calculate it. That's what net force 0 means. Okay, for this question, right, I am question number 4. Question number 4, I'm just quickly, I'm trying to answer all the combined science questions for, all the questions for, which applies to combined science also. Okay, pressure is, what is pressure, guys? Pressure is the force acting per unit area. Force acting per unit area. Okay, force acting per unit area. It comes from pressure equals to force over area. Now, part B just applies to pure physics students. Just quickly go through. One of the tallest barometers in the world contains oil. And you know barometer, right? They're asking you They say the density of the oil is known. So you know pressure of a liquid is given by H rho g. They said how this barometer is used to measure atmospheric pressure. So what actually happens is atmospheric pressure exerts X here on the surface, right? And that is also equal just to the height of this one. Okay, normally we use a mercury barometer, but in this case, they are actually using oil. And because the density of the oil is smaller than mercury, it actually gives you a very tall barometer. So they said, state the name of any instrument used. They said, how can this barometer be used to measure atmospheric pressure? So basically, you can say that the atmospheric pressure, okay, see this? This is the part where, you know, the air pressure that all of us experience now. Pressure X on the surface. Okay, X on the surface of the, okay, surface of the tank. Okay, X on the surface of the oil or the container with oil. This, okay, pressure. Okay, you can see the pressure. You can put down the pressure exerted by the column. So this is the column. The column is this one, the glass tube. By the column of oil. In the, you can put there the column of oil in the glass tube. Is the same. Okay. K is the same, all right, at the same level. So where do we talk about at this point? The pressure here and here everywhere is the same. Okay, at the same level. The pressure of a liquid, guys, the formula for pressure of liquid, right, is H rho G. Okay, so to measure atmospheric pressure, so the pressure of the liquid is to measure H. It can be compared, okay, because they actually use the person there, right? Okay, it can be compared to height of, to the height of man or person, about 1.7 meters. Okay, this is a one way to estimate lah. It's an estimate, right? Okay, so it kind of based on the diagram, and it is about the height of 5 men. Okay, another way to do it, right? Guys, this is one option, right? To measure the height, it can be compared to height of a person. Okay, another option is to use a measuring tape. Okay, they talk about the apparatus, right? Use a measuring tape. Okay, they state the name of any instrument used. Use a measuring tape to measure from the level from that level to top of column against the building, right? Measure using the building lah. Okay. So guys, what is more important is you need to know that the atmospheric pressure acts on the surface of the oil and the pressure of the column of oil just above, right? The column of oil, the height of it gives you the pressure is the same. And the pressure of a liquid is given by H rho G. So you're just trying to measure the H. So you can suggest two ways to measure H. So of course, you don't need to write both as long as you write one. Now, this is not a very typical kind of thing. They actually wanted you to compare against the height of the man. So that's the part which comes a little tricky. But overall, this part of the question is quite standard lah. Okay, this is a standard answer. It's just that how do you measure it? Okay, because they actually put a diagram of 5% and then they actually go and, so the actual height to be measured, you can actually draw in your drawing the height to be measured. This is the height to be measured. You can indicate in your drawing. So you can just say, oh, I will measure this height H using a measuring tape. That's fine. Okay. All right. We continue. Okay. The students, combined science students, we will continue with questions which are applicable to both pure physics and combined science. Okay, guys, if you have to, you can take a screenshot of this. All right. Complete the following. Complete the following three statements about waves by writing in each of the gaps. Okay. So, guys, longitudinal waves, the vibrations are parallel. Very good. Parallel to direction of energy transfer. In transverse waves, vibrations are perpendicular to direction of. And waves transfer energy without transferring matter. Very good. Okay. 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 So they transfer energy without transferring matter. Okay, let's take a look at this. They say a loudspeaker emits a sound wave. Okay, loudspeaker emits a sound wave that travels at a speed of 340 meters per second. Okay, they say the displacement time given. Now, guys, please be careful. Look at that. This is millisecond. I repeat, please look at your axis very carefully. They say calculate the frequency. So the period 4 millisecond. 4 millisecond, guys. 4 times 10 to the power. Okay. Okay. 3 seconds, right? Milliseconds. Okay, so please be careful. So frequency 1 over 4, 10 to the power minus 3. You work it out. Okay. Okay, you get this answer 250 hertz. Okay, so please be careful. Don't forget the units. Now calculate the wavelengths. Okay, it's not 4,000 hertz. Please be careful. Okay, use the formula carefully. So, okay, you said how many periods they are, right? So because I see one full wave, I have to measure one full wave from here to here. This is the one full wave. What? This is one full wave. So, I mean, you can go and find out that, but I just need to worry about the one full wave. If I go and read two full waves, then I have to divide by two. Yeah, correct. One full wave is the time taken for the period. That's right. Now, wavelength, you know this formula, V equals to F lambda. So what is the speed of the wave? The speed of the wave given as 340, 340, 250 wavelength. So you work out the... No. If there's two period, if it's two period, if your wave is two period like that, and you don't multiply by two, it's not two times this. If it's, let's say, for example, this is 4 times 10 to the power minus 3, then that means the period is 4 divided by 2 what? Cannot be 2 times that. Okay, so you have to be careful. If let's say they give you 2 cycles and then they give you the time like this, it means the period is just based on this. Okay, it's just based on this part only. So this is the period, what? So this is actually 2t, see? If that's the case, if that's your question, if there are two waves, so you have to divide by 2. Okay, so wavelength is 340 divided by 250, and you get 1.36 meters. Yeah. If they give you the wavelength, yeah. If they give you the two waves and then the wavelength, yes, of course you have to divide by 2. Because it's all based on one full wave, you see. So if they give you the length based on 2 waves, then you have to divide by 2 to get the wavelength. Now this one is tricky. Point Y is 1/4 of a wavelength further from the loudspeaker than X. They say this part is 1/4 of a wavelength further from the loudspeaker than X. They say draw the displacement time graph for the air at Y. Now remember this particle, if it's one wave, it's a quarter of a wavelength, right? A quarter of a wavelength further. So the oscillations are going to be just that little bit slow, that 1/4 of a period slower. So if it's 1/4 wavelength further, that means if this thing, right, look at that. If this thing starts here, so technically this is 1/4 of a period, right? So that particle, look at it this way, 1/4 wavelength further. That means that particle there will also, its motion will be kind of 1/4 of a period behind that of this particle here. So this is 1/4. This is the 1/4 point. So you can start and draw this particle like that. Okay, you can draw this particle like this. So you can draw the wave of this like that. It should be 1/4. So whatever it is, it will reach everything. So technically this wave will be here. Okay, guys, this shows that this particle, guys, you must draw the curve as smooth as possible. Okay, because I'm drawing it on the screen, it's not as good, but it should be the same sign. But the reason why I started here is to be 1/4 later than the first particle. This is the first particle, and this is the particle which is 1/4 of wavelength later. So you just shift this graph by 1/4. So the same graph will repeat, but 1/4 of a wavelength later. Okay, so take note of that. All right. What is okay? This part. Okay. For combined science students, we don't really need to know. Yeah, maybe the focal length. Yeah, is the focal length of a converging lens is the distance between center of lens or the optical center and the focal point. Okay, is the distance. The focal length is the distance along the principal axis. You can say that, yeah. Okay, so the focal length of a lens is the distance between the center of the lens and the focal point. So I'm just giving you a straight, easy answer there. Okay, now we have a converging lens. Now, combined science students, you don't really need to know how to draw the ray diagram, but you still need to know what's a virtual image. What is a virtual image? A virtual image is the one where the image cannot, yes, correct, cannot be projected on a screen or cannot be projected or captured on a screen. Very good. Okay, cannot be captured or projected on a screen. Now they said draw rays from the top of the object to show how the image is formed. Now, guys, the thing is this: we don't know exactly, right, where they want you to find draw rays from the top of the object to show how the image is formed. You know one thing for sure is that they are standard rays, right? So there are some standard rays to draw. Okay, we are going to use the standard rays, right? One ray is the ray that will pass through the ray that will pass through the center like that. Okay, from the top of the thing, okay, this rays. Okay, this ray will pass through. Now, what you do know is that the other ray will be like that. Okay, by right, okay, if I were to draw this ray to the center, okay, this other ray should go like this. Okay, let me use another color. Okay. Okay, guys, actually by right, the rays on this side, right, should be dotted. The rays on this side should be dotted. Okay, so you pull it back. You pull it back here. Okay, draw a straight line and then you can find your focal point. Okay, you can find your focal point. Okay. So you draw, guys, actually you shouldn't stop there. I think if you draw it correctly, this point will be your focal point. Okay, this one will be your focal point. Just draw a straight line. And then this point here is your focal point. So these are your rays. Now by right, these two parts here should be dotted. Because you are getting virtual. This is a virtual image. So this should be dotted. Okay. So guys, if you actually work it out based on the thing, what's the focal distance, focal point? If you work out correctly, it should be about 4 cm. Okay, this one, the focal length 4 cm. Okay, so this is the technique of drawing the ray diagram. That is the technique of drawing the ray diagram. Okay. All right, I'm going to just erase this image. I think just very quickly take a screen grab of this, please. Okay, if you have to take a screen image, please do that. Yeah. All right, let's take a look at question number 7. A student measures current and potential difference in order to determine the resistance of a fixed resistor. Okay, so here it shows an incomplete circuit diagram. So she's trying to measure the current and potential difference, right? So of course the current, right, guys, the emitter should be in, yeah, emitter in series, very good. Emitter in series and the voltmeter in parallel, correct? This is voltmeter in parallel, right? So this is the voltmeter, this is the emitter. Okay, it said different readings are obtained by adjusting the variable resistor. The largest and smallest readings are given here. So calculate the resistance of the fixed resistor. So you can choose any one of these values and work it out. Okay, you can work out using one of the values here. Okay, so they ask you what is the, yeah, you calculated it correctly. So resistance, because they say it's fixed, right? V over I. So you can use 18 divided by 1.50. Okay, you can get 12 ohms. Okay, 12 ohms. Now, explain why a current smaller than 0.4 cannot be obtained. So you see the variable resistor, why you cannot get smaller current than that? Because the whole idea of the variable resistor, this is the one that varies the current, right? You're using this to vary the current. And how do you do it? You can say that the variable resistor has a length of resistance wire. Okay, so it's actually you're changing the length of the resistance wire. Actually, remember our resistance from this formula here is directly proportional to length. So as the length of resistance wire, it can be set to a maximum. Okay, you can have the length such that it is a maximum. Hence, the current, because you're setting the resistance or the length to a maximum, the current cannot be smaller than that. Okay, because you set the length to a maximum, hence you can only set, you can say that okay, what this means basically, right? What this means is you are controlling the current that flows here by varying this. So basically what you're trying to say is this variable resistor, no matter what, can be, there's a maximum value, can be set to a maximum resistance. So you cannot go more than that, you see. You cannot vary the resistance of this beyond the maximum. So in a way, you are limited to decide how much current can flow through. So the simple answer is the variable resistor has a maximum resistance, which cannot go beyond that. That's why the current cannot get smaller than that. That's the simple answer to this. Because the whole experiment, you are changing the current by changing the resistance of the variable resistor. So once it is set to a maximum, then the current cannot get smaller than that. That's all. Okay, so now we come to this formula again. A fixed resistor is a metal wire. Second metal wire is made from the same material. So remember this formula. Resistance, this is the property of the material. This is resistivity. Yeah, good. Those of you who have done it, good. So this one, no change because it's the same material, right? The same material means rho is the same. Now, the formula for resistivity and density looks the same. Now, they said, what will be the resistance if it's twice the length and twice the diameter? Guys, look at that. Can you please underline this? Twice the diameter. So the new resistance, right, is rho 2L. Now, you need to go and find out what is the area. The area, the original area is pi. Okay, if I were to use it in terms of, diameter, it's pi. Twice the diameter is the same as saying the radius is twice, right? This pi r squared. Okay, when my diameter is double, it becomes the new area is pi 2r squared. Okay, double the diameter means double so it becomes 4 pi r squared. So technically this area A2 is 4 times A. Can you see that? It's 4 times A. So it's 4A. So overall, the new resistance, if you compare to the original resistance, this is the original resistance, but the new resistance, double length, but area is, it will become rho L over 2A, which is basically half of R, So what did you find here? 12 ohms, right? So this one will be 6 ohms. So guys, please be careful. This type of calculations can come out. This calculation comes out as an MCQ or structured question. This is a very popular question and comes out quite often. All right, question number 8 is on electromagnetism. Figure 8.1 shows part of a long wire in which there's a current in the direction shown by the arrow. Okay, so basically, guys, how do I find magnetic field, the field in a current carrying wire? I use right hand grip rule. Guys, if you use your right hand grip rule, you will find that the field is coming out of the paper like that. And here it's going in. Okay, the field here is going in, right? Yeah, correct. So you have to say that the field here is coming out and here is going inwards. This is coming out. Guys, you use your right hand grip rule, you will know what I mean. The thumb points in the direction of current. So the current in the wire creates a magnetic field, right? So this is the field coming out and this is going in. So they say describe two ways in which the magnetic field at P differs from. Now, if you look at it, P is closer to the wire. P is closer to the wire than Q. First, you can say the field at P, the magnetic field at P is coming out of paper, Q is going in. Or you can just say the direction of the magnetic field at P and Q are opposite to each other. You can just say direction is opposite. I'm giving you more specifically. P is coming out, Q is going in. The other one is because P is closer to the wire. Look, P is closer to the wire. The magnetic field at P is stronger. Okay, why stronger? Because Guys, why is it stronger? Can use right hand. Yeah, right hand grip rule. The right hand grip rule in this case helps you to find the direction of magnetic field. The thumb points for a current carrying wire, the thumb points in the direction of current, and the flex fingers, the direction of field. Yeah, yeah. So, yeah, because P is closer, so the magnetic field at P is stronger. Okay, you can say that the magnetic field at P is stronger. So that I'm just giving you an explanation, but you can figure it out. Okay, you just have to say basically is one is about the direction, the other one is the strength. Okay, so you can use your right hand grip rule and figure out. Okay, the next part is Fleming's left hand rule. Guys, you use Fleming's left hand rule. Using Fleming's left hand rule. Guys, can you tell me what's the direction of the force? Okay, left hand rule. Okay, this is the current. The magnetic field, guys, don't get it wrong. Magnetic field is like this. This is the direction of the field. Current is like that. And the force, guys, can you try it out? Use your left hand rule and tell me what's the answer. Yes, very good, Gabriel. Yeah. The force is into the paper. Guys, if you do it correctly, you'll find that the force is like that. Okay. You follow B downwards, current, follow that. Okay. Current this way, the thumb will point inwards. It's into the paper. Okay, very good. So how did I determine the direction of force? Using left hand rule. Using Fleming's left hand rule. The forefinger points in the direction of magnetic field. The second finger points. So you have to say they are all perpendicular to each other. Direction of current, thumb points in the direction of force. Okay, you can put there that all three are perpendicular to each other. Okay, perpendicular to each other. Okay. So use left hand rule. The forefinger points direction of magnetic field. The second finger points in direction of current. Thumb points in the direction of force. So you're just explaining how you use Fleming's left hand rule. Okay, points in the direction. Okay. All right. Okay, we'll come back to this question on data analysis. Okay, let's go to the question number 10. Specific latent heat. Okay, specific latent heat is the amount of energy to change 1 kg of a substance, the state, the change 1 kg to change from one state, because this is general, right? From one state to another without change. Guys, you must say about the part about without change in temperature. Okay. change from one state to another without a change in temperature. The amount of energy to change 1 kg of substance, or you can, of substance from one state to another without change in temperature. Now, state the difference between latent heat of vaporization and latent heat of fusion. So the latent heat of vaporization basically involves what? Latent heat of vaporization involves latent heat of vaporization. Okay, I'll just write down this. Vaporization involves change from liquid to gas, or you can put there vice versa, right? Okay. Fusion, change from solid to liquid. Okay, of course, it can be the other way around, but this one, vaporization is liquid to gas, fusion is solid to liquid. Okay. Okay, these are things that you actually learn from lower secondary, right? Okay, what you see here is the heating curve. Now, they show that the variation with time of the temperature of a fixed mass of substance. Thermal energy is gained by a substance at a constant rate. Guys, look at that. It's gained at a constant rate. So the power supplied is constant, right? Okay. So they said in region A, substance is a solid. So guys, can you tell me what happens in B and what happens in D? This one is liquid and this one is gas. So what must have happened at B? B is where what happens? Yeah, melting, right? Melting. Okay, we don't need to talk about evaporation. This one is, okay, don't confuse. Yeah, the first one is melting, occurs at B. And then what happens here is liquid changes to gas. Now, remember, when something changes state, you can have both liquid and gas. Here, you can have both solid and liquid. So boiling occurs at D. Yeah, correct. Okay, next. Change the state the changes that take place, if any, to the kinetic energy. Now, remember, when something changes state in region C, look at that. The liquid is just getting hotter. So temperature increases. Temperature increases. Guys, when temperature increases, remember kinetic energy is related. Ke is directly proportional to temperature. So Ke increases when temperature increases, okay? But potential energy depends on the change of state or how far the molecules are from each other. So because there's no change in state, it stays the same. Now in region D, which is actually the change of state, right? When there's a change of state, no temperature change. So kinetic energy is the same. No change, right? Temperature constant. Potential energy will increase. K increases as, why does it increase? As the change of state. Okay, just put there change of state. Particles get further. Now, use figure 10.1, state and explain how you know that the specific latent of fusion compared to the specific latent heat of vaporization. Okay, we want to compare the latent heat of fusion and latent heat of vaporization. So look at this, guys. This is the part where heat is supplied. This is the latent heat of fusion. Okay, change of state, solid to liquid. Look at that. State of, this is the vaporization. Now, they said power is constant, but look at the time. The heat supplied here is power times time 1. The heat supplied here is power times time 2. You can see the time here is longer. Okay, look at that. It takes, the time is longer. So that means the heat supplied, so the vaporization, you can say that latent heat of vaporization of substance is larger or higher than latent heat of fusion. The time taken for boiling is longer than melting. Hence, more energy is supplied for a constant power. Okay. How do you know? Because energy is power times time, you see. Okay. So you know that the vaporization is larger, higher than the latent heat of fusion. The time taken, based on the time taken, boiling is longer than melting. Hence, more energy is supplied for a constant power. Okay, so this is how you compare the latent heat of vaporization and to the latent heat of fusion. So it's bigger because the time taken is longer for boiling. Okay, guys, please take a screenshot. We have to, yeah. All right, let's take a look at this. EMF. Okay, this question is on DC circuits. Now, the EMF of a battery, the EMF is the work done. Okay, the EMF is the work done by a source to drive a unit charge. Or you can say to drive a charge through the circuit. Okay, so EMF is actually this formula is the work done to drive power supply to drive, or you can put a unit charge. Okay, is the work done by a source to drive unit charge, work done to drive a unit charge through the circuit. Guys, can you please work out the resistors here, please? What is the effective resistance? Very good. Some of you are very fast, huh? Okay, you work it out because you can see all are effective. Okay, these are the questions you want to get right, huh? Okay, you work it out, are effective. Now, don't forget to inverse it, 15 ohms. What is the electrical quantity the same for all resistors? Voltage or potential difference? Okay, voltage or potential difference. Very good. 15 ohms, yes, correct. So what is the same? Now, this question is a little tricky. Now they are talking about the IV characteristics. Now you have to follow this carefully for a resistor R and a filament lamp. Now this is for the lamp. This is for the resistor. You can see straight away R is ohmic. This is ohmic because it passes through 0, 0 and it's a straight line. Whereas the lamp is non-ohmic. Okay, this is the I and this is the V. They said, what happens to the resistance of R and resistance of L as voltage increases? R remains constant because it's ohmic. Okay, R remains constant. But look at L. L, you can see that the V increases more. The R is V over I, right? But you can see that and when the V increases, the I increases, but not as much. So the V increases more than the I. So the resistance actually increases. Okay, as the voltage increases, as the voltage increases, the resistance increases. Okay, V increases more than I. Yeah, no problem. Yeah, welcome, Robertson. Okay, the resistor and the lamp are connected to a variable voltage power supply. So now they are both connected here. They are connected in series. Okay, and here they are connected in parallel. Now, in series, the current must be the same. I through both must be the same. They say the power supply voltage is adjusted. This one is adjusted until the current in each circuit is 0.6. Now, the interesting thing is this. If this is 0.6, the current here and current everywhere must be 0.6. So they are saying different power supply voltages are needed in the two circuits to obtain the same current. Use figure 11.2 to determine the EMF of the power supply for 11.3. Now, guys, if the current through R and L are both 0.6, look at that. Look at this. Where is it? Where both of them have the same current. So it's this point here. Can you see 0.6? Both of them have the same current of 0.6 here. So what is the voltage across that? So the voltage across R is 6 volts. And voltage across L is also 6 volts. So this, both are 6 volts. Remember in series, 6 volts, 6 volts. Now you add it up. You must add it up because in series, you must add it up. So the EMF is 6 volts plus 6 volts, 12 volts. Okay, please go to the graph and see what I'm doing here. Here, the both of them have the same current. Okay, 0.6, 0.6. So 6 volts, 6 volts. Now the next one is interesting. They say, explain why the EMF of the power supply in figure 11.4 must be 2 volts. Now, you want the current in here to be 0. Look at it, it's parallel, right? Okay, 2 volts. If this is 2 volts, look at that. They give you 2 volts. So you know in parallel, this has to be 2 volts. This is 2 volts. Both will also be remember, potential in parallel will be the same. So 2 volts, 2 volts. You go to the graph. You go to 2 volts. Look at that, 2 volts. When both are 2 volts, look at the current here. The current in R is 0.2. The current in L is 0.4. You go and add it up. Okay, you can see that it will become 0.6. So this is how you analyze it. When the PD, when they are in parallel, the PD is to be the same. So 2 volts. So you can say that when the EMF of power supply the current in R is 0.2. Okay, look at it. 0.2 ampere. And L is 0.4 ampere. And total current is 0.6 ampere. So you add it up. Okay, remember what actually happens is the current that goes here, 0.2, and the current that goes here is 0.4. You add it up, it becomes, when this is 2 volts, the total current will be 0.6. So you'll split as 0.2 and 0.4. Okay, that's what this thing is showing you. All right. Okay, this is the either or question. Now, this one transformer is from, where do we get transformer is from the topic of EMI. Now, why do you need the iron core? Guys, what's the purpose of the soft iron core? One, the soft iron core will enhance the magnetic. Yes, very good, Gabriel. Easily magnetized is correct. One is will enhance the magnetic field link gauge between primary coil and secondary coil. Okay, the next point is very good. Because magnet iron core is easily magnetized. It's a soft magnetic material, easily, it can basically, what it can do, right? It's a good magnetic material. It's a soft, good magnetic material. So it can easily change polarity. Polarity means direction. Polarity means direction. Okay. So changes in magnetic field. Changes in magnetic field are experienced by secondary coil. Okay. Now, this part of the question, yeah, I think for combined science students, it's not exactly, but you just need to know about the fact that it's a good magnetic material. Okay, so you can talk about the induced EMF. Guys, what's the formula for turns ratio? Primary coil, number of secondary to number of primary is. So what was the original voltage? 230. So you can substitute here. This is secondary. This is secondary. This is primary. And this is 12. Okay. You can play around with this. Okay. Yeah, very good, Lemol. Yeah. If you work this out, guys, very good. Some of you have worked out very fast. 48 turns. Okay. The secondary is 48 turns. This is your turns ratio. Okay, so this is the formula. Okay, what's the circuit symbol for fuse? Okay, and why must the fuse be connected in series rather than in parallel? Because the fuse breaks the current flow into an appliance when it exceeds the rating. If it is in parallel, the current may continue to flow to appliance as the branch, okay, as the appliance, as the fuse may, the current will continue to, if let's say the appliance, let's say for example, the fuse, right, is here and the appliance is here. This is connected to the appliance. Okay, so if the current exceeds, right, the current can continue to flow into the appliance as the fuse cannot, as the fuse break does not stop current flow to appliance. Okay, current can continue to flow to the appliance. Okay, guys, the thing is you need the thing both to be in the same they should be in the same loop lah, or they should be in series. If not, it will not break. Right, identical lamps rated at 12 volt, 8 watts are connected in parallel across the secondary coil. The efficiency is 90% when lamps are connected. Calculate the number of lamps that be connected across the secondary coil. So first calculate the power supply. Power supplied by primary coil. V times I. 230 times. Okay, you calculate the current. You go and calculate the current in the. If you go and calculate the current in the primary, right? Okay. It's 46 watt. Okay. So maximum power okay. Hold on. Maximum power in secondary is 0.9, 90%. 46 watt, 41.4 watt. So you go and calculate 41.4 divided by 8 volts. From here, you find that maximum number of lamps is 5 lamps. Okay, 5 lamps in the circuit. Okay, so you're just using the power formula, and then you use 90% of it, 41.4, and then you work out, divide by this is the power in the secondary. Power in the secondary. Okay, guys, if you have taken a screenshot of this, please. Okay, we go to the data analysis question, everyone. Okay, everyone start reading the data analysis question. Okay, that's our last question here. Okay, right. An electric car is powered by an electric battery. Total mass of the car is 1,400. They say what's the kinetic energy? Now, in joules. Now, remember this given is 90 kilometers. So you must change it to meters per second. So 90,000 divided by times 1,000, right? Divide by 3,600. The speed in meters per second, right? Go and find out what is the speed in meters per second, 25 meters per second. Then you use half mv squared. Cannot use this value, you must change it to meters per second. Okay, you work it out. Okay, you get 4. Okay, guys, work out the correct value. Okay, please be careful. Work out the correct value, 1,400 times 25 squared. 4.4 times 10 to the power 5 pascals. Joules, sorry. 4.4 times 10 to the power 5 joules. Okay, it's actually 437,500. All right, this one is quite interesting because now you know all Singapore all got EV cars. So chances are you can get questions like this, okay? Energy used by an electric car and then a similar petrol car shown. When fully charged, a battery stores 30,000 watt-hour. They give you the energy in terms of watt-hour. Guys, you must know how to use the data given. The average energy used by a motor in an electric car for a journey of 1 kilometer. For urban driving means like on all the roads that we travel before the highway. This one is like your CTE, PIE, SLE, all this. Obviously, when you travel on the highway, the energy consumption is lesser. These are all the roads that links you between, with all the traffic lights. You're going to consume more energy. Now, the energy stored in 1 kg of the battery. So you see, there's a bit of data. You just have to be careful with dealing with it. 130 watt per hour. Now, whereas the 1 kg of petrol gives you 13,000. So straight away, you can see it's 100 times more. 100 times more. This is 100 times more. Okay, the efficiency of conversion from the electrical energy in the battery to output of a car, 80%. The chemical energy in a petrol to output is 20%. So this is only 20%, whereas the other one is 80%. So guys, just take note of all this information, apply accordingly. This is like a comprehension, like I'll consider this like the comprehension of the physics part. When charging electrical energy, now got a lot of those charging points, right? Singapore, they are slowly building all the charging points. They say that when you want to charge the EV car, when you do at the level 2 charging point, 7.4 kilowatt, and at the supercharging point is 50 kilowatt. Okay. First, the electric car is driven for a long journey. 50% of the distance is on the highway. 50% is urban driving. So it's half-half. Half-half. So they said, calculate the average energy in watt per hour used by the motor car for each 1 kilometer. So guys, look at that. If you look at that, urban driving, 160 kilowatt. Highway, 140 watt. Okay, watt hour, sorry, 160 watt per hour. So highway, 140, highway is 140. So basically, 50%, 50%. For each kilometer, you just do 160. So basically, it's just taking the average. So it's 150 watt hour. Okay, 150 watt hour. So you're using half of urban driving, half of highway driving. Now, calculate the maximum distance a fully charged electric car can travel in urban driving. Okay, so a fully charged means got how much? Go back to this. Fully charged, 30,000. Urban driving is how much? 160. What's the maximum distance? So you just go 30,000. Okay, 30,000. Okay, and they're saying that the energy stored in 1 kg of the battery, right? Okay, what's the maximum distance a fully charged electric car can travel, right? So you know that it's 160. Guys, look at that. Watt hour per kilometer. So per kilometer, 160 watt hour per kilometer. So you work it out. This is watt hour, right? So I look at the value I'm dividing. 187.5 kilometers. So you can put there 188 kilometers, or you can put 190 lah. Now calculate the mass of the car battery. Mass of the car battery, okay, the car battery. So 1 kg of the battery is 130 watt. 1 kg gives you 130 watt, right? So you can work out 30,000. It's just like comprehension, guys. Just use the correct data. Okay, depending on what they are asking you to find. Okay, so it's 230 kg. 230 kg. Right. Now, here's the interesting part. A petrol car and a fully charged electric car have enough energy to travel the same maximum distance. Okay. The manufacturer of the petrol car claims that the mass of the battery in an electric car is 25 times larger than the mass of petrol needed for the petrol car. So let's take a look at this using data from table 9.1. You already know that 1 kg of petrol provides 13,000. 1 kg of battery gives 130. But look at the efficiency. Guys, you have to also take into account the efficiency. So for the battery, let me use the petrol first. Petrol, 13,000 times, remember it's only 20%, right? 0.2, you have 2,600 watt hour. For battery, it's 130 and it's 80% efficient. So this is 104 watt hour. Okay. So take note that I use the values there given and then multiply by the efficiency. Okay. So for the electric car to match the petrol car, right? So for the electric car to match petrol, right? Because look at this energy available and look at the energy available here. This is based on every kilometer. This is based on, every kg. 1 kg of petrol. This is 1 kg. This is 1 kg of petrol, and this is 1 kg of battery. So for the battery to match this, right, you take this 2,600. You compare petrol over 104. You'll find this to be 25 times. Okay, you find this to be 25 times. So that means that of petrol. Hence, the claim is correct. This claim is correct. So guys, as I just want to tell you, initially, actually, if you look at it, maybe at the start, this question can look a bit threatening. By the way, the data analysis no longer comes as part of section B. From the year 2024, yeah, you have to put the working. You have to put the working. Okay, you must always put working. Okay, guys, from the year 2024, the data analysis no longer comes as in section B. It just comes as section A. Section B, there's an either or. Whether it's for pure physics or combined science, the section B is just an either or. There's only 2 questions. You choose one, right? Okay. Now, determine the time taken to recharge a fully discharged electric car at level 2 charging point. So you want to, you need 30,000, right? When it's fully charged is 30,000. They're asking you what is the time taken, right? This is 7.4 kilowatt, right? 7.4 kilowatt. Guys, don't forget it's 7.4 kilowatt. 7.4 kilowatt. You'll find this to be, this is watt hour, and this is watt already. I change it to watt. So 4.05 hours. Okay, this is 4.05 hours. Now, some of you will find this interesting because you have an interest for EV. Now, remember, data analysis, right? Even though the context may not be something familiar, but all the calculations are just based on all the physics concepts that you know. So there's nothing to be frightened of. Whatever they ask you will be just based on all your normal physics formula, all the things that you learn in your syllabus. It's just that the context may be a bit new, that's all. All right, let's just look at the last part. Suggest why the 230 volts electric supply to an ordinary home cannot be used at a supercharging point. So look at that. Supercharging point, if you use the 30,000, this is your power, right? So you go and calculate what is the power here. At the supercharging point is 50 kilowatt. 50 kilowatt. So you know power is VI. It's 50,000 I. And you find that your I is 208 ampere. Look at this. This is a very high current. So you can say that this current is way too large. Too large for household electric supply. Okay, so we're just making use of this formula. So guys, remember, data analysis is all about using the appropriate data. Just choose the correct data for that question and be confident to apply the physics formula that you know. Okay, like what I said, initially it may look a bit frightening, but as you do the questions part by part, you can actually do all these questions. Okay, so what I want to say before we wrap up this is that, see, you get a sense of the kind of questions they ask. Now, if you have not done your 10-year series, whether it's pure physics or combined science, physics or chemistry. Guys, when you do, only when you do the 10-year series, you get a idea of what kind of questions they ask. You get to apply your timing. Okay, what are the topics they like to repeat? Okay, you can check your answer against the answer key. All right. As you keep doing this, a few of these papers, your confidence level will get better. All right. Try to maintain this. In fact, this applies across all your O-level subjects. Okay. So continue working hard. Okay. Uh, and if you just maintain this, and I hope you have learned quite a bit from today's session and you gain a bit of confidence. So all the best for your O levels. Okay. If you have any questions, you can always drop me a text. Yeah. Okay. You can, I'll just give you my number. Okay. Some of you actually know me already. Okay. You can take note of my number. If you're unsure, you can just ask questions. Okay. Okay, that's my number. All right, guys. Hope you had a fun session. Not really fun because we had to go through it quickly, but most of you participated. So I hope this has been useful. All the best for your O levels, guys. All right. Take care.